Okay, students. Now, another concept of finding the pH for different type of solution is that of a mixture of two weak acids. We have got a mixture of two weak acids. Example we will take up here of formic acid and acetic acid. Suppose these two acids have been mixed together, and in the resultant solution the concentration of formic acid is C1 while that of acetic acid is C2. Both the acids, as we have discussed here, are weak acids, so both of them will establish one equilibrium. And how the equilibrium is going to be: formic acid will give you formate ion plus H plus ion, while acetic acid gives us acetate ion and H plus ions. Now, the degree of associations may be same or may not be same depending upon the concentrations as well as Ka and K2 values, but we assume here that degree of dissociation of formic acid is alpha 1. So, the equation becomes C1 into 1 minus alpha 1. This will be C1 alpha 1 and C1 alpha 1. While in this case, the degree of dissociation we assume to be alpha 2. So, this becomes C2 into 1 minus alpha 2. This becomes C2 alpha 2 and C2 alpha 2. Now, we write equilibrium constants which are called as Ka1 and Ka2 for these two, and Ka1 we assume is the dissociation constant for formic acid. So, this will be Ka1 equal to concentration of formate ion HCO minus into concentration of H plus upon concentration of formic acid HCOOH. Right. Now, if you see, concentration of formate ion here is C1 alpha 1. So, this we write it as C1 alpha 1 into concentration of H plus ions. See, that's what we have been doing here. Whenever you are putting the concentration of any species, this must be the total concentration of that species present in the solution. Here, concentration of H plus we are getting from two things. Number one, by dissociation of formic acid. Number two, from dissociation of acetic acid. So, we have to write total concentration of H plus ions here, which will be C1 alpha 1, which is coming from formic acid, plus C2 alpha 2, which is coming from dissociation of acetic acid, upon concentration of formic acid, which is C1 into 1 minus alpha. Right. Now, second one, we write equilibrium constant for acetic acid. We assume it is Ka2. So, this will be Ka2 equal to similar manner concentration of acetate ion, CH3CO minus into concentration of H plus upon concentration of acetic acid CH3COOH. Now, concentration of acetate ion in the solution will be equal to C2 alpha 2. Again, concentration of H plus ion will be kept as total concentration of H plus ions, which is C1 alpha 1 plus C2 alpha 2 upon concentration of acetic acid undissociated one, which is C2 into 1 minus alpha 2. We got two equations as well as two variables, which is alpha 1 and alpha 2. Concentration will be given to you as well as Ka1 and Ka2 values will be given to you if he is asking you the final pH. Now, what about final pH? If these two equations are solved, we get alpha 1 and alpha 2 values. Now, final pH of the solution will be taken as pH equal to minus log of C1 alpha 1, which is concentration of H plus coming from formic acid, plus C2 alpha 2, which is concentration of H plus coming from acetic acid. So, after doing this, we can get the answer. One more thing you understand here, that in this case what happens, that this alpha 1 and alpha 2 have been assumed to be degree of dissociation. These alpha 1 and alpha 2 have been assumed to be degree of dissociation in presence of each other. And if you can understand one more thing, in presence of each other, the dissociation of both of them is going to decrease. Why? See one thing, in the dissociation of formic acid we are getting H plus ions, as well as in the dissociation of acetic acid, again we get H plus ion. This H plus ion will exert common ion effect over this one, and this H plus will exert common ion effect over this one. As a result, the dissociation of both the acids decreases further. Now, if you try to solve in this manner only, the calculations become very difficult. Here comes the approximation part, and this is how we take the approximation, because already both the acids were quite weak, and now we are adding both of them together. As a result, due to common ion effect, the dissociation of both the acids decreases. Once it decreases, the alpha 1 and alpha 2 further get suppressed. So one of the approximations which is taken here comfortably is that these values can be neglected in most of the cases as compared to 1. Got it? Now if you see further, this gets cancelled anyhow in this manner. And now if you simply divide these two, you see these two equations, we simply divide these two, we will get from here Ka1 by Ka2 equal to, you see this, once we divide them they will get cancelled, and we will get Ka1 by Ka2 equal to alpha 1 by alpha 2. Right or not? Clear? So we got a ratio of alpha 1 and alpha 2 from this equation. K1, K2 will be given to you. If this we substitute here, one in terms of other one, we will get the value of that particular one. After getting the particular one, you substitute it again here, you will get, suppose previously you calculate alpha 1 from here, this equation. Now you substitute the value here, you will get alpha 2. After getting alpha 1, alpha 2, substitute them here, we get the pH of the solution. Okay.